Okay. Hello everyone. Can you hear my voice? Am I audible?
Yes, sir.
Everyone, please give your attendance. Uh, Everyone, please mute yourself. Okay. So let me start my class. Uh, in our previous class, we already discussed about everyone, please give your attendance. So in our last class, we already discussed about harmonic function and also two-dimensional flow, two-dimensional heat flow, and I just solved some problems, including boundary problems. Okay, so our boundary conditions. So here I will give you another example. So here del u by del t del square u by del x square. This is our heat equation, one kind of. So foundation will be this. Okay. So we have to solve this boundary problem, boundary value problem, which is del u by del t equals to del square u by del x square, 0 less than x less than 1, where the limit of x and also t greater than 0. And here also the boundary condition is u0 comma c equals to u1 comma c equals to 0. Okay, and ux comma 0 equals to c times 2 pi x. This is our boundary condition. And in our previous math, we just saw that we just give uh, the initial condition and also solve some partial problems. Okay, so here this is our boundary condition. Okay, you have to solve this kind of problems by using separable variable method. Okay, so at first here given the equation 1 and also use 0 t 0 2 so 3 equation 3. Okay, and after that is x equals 0 0 equation 4. Okay. Now you have to solve this kind of problems. You have to let u x comma t. Here the independent variables are t and x. So you have to let the function u, which is a function of x and t. Okay. So u to x comma t equals to x into tt. Product method or separable variable method. So at first we need to consider equation 5. Okay. Where x, so now tell me what we have to do in our next step. Here we use the product method, which is u x comma t equals to x into t t. So now what we have to do after that? Anyone? Okay, so you have to partially differentiate u, okay, with respect to t at first, and also x partially uh, two times. Okay, you have to partially differentiate u also uh, with respect to x two times, and where u equals to xt. Okay, now you can say from here that del u by del t is xt prime, and also del square u by del x square is x and prime. Okay. Now put these things in equation 5, you can get from, you can say u equals to, not equation 5, now equation, which is our equation 1. Okay, যেটা দেওয়া ছিল del square u by del u by del t equals to del square u by del x square. So you can say this is x is prime equals to here x double prime t. Okay. Now from
স্যার
here
ওইটা কি ধরে নিছি আমরা
কোনটা?
স্যার del u
Yes,
by del
this
t
is the
equal to
এখানে কি দেওয়া আছে? Here ux comma t equals to xx plus t equals. So I just said that you have to solve this kind of boundary value problem by using three methods. One of them is Fourier transform, another one is Laplace transform, and the third one is product method or separable variable method. Okay. So I just use here product method, which is ux comma t equals to x t. Okay. Now just your given equation is del u by del t equals to del square u by del x square. Okay. So here you can say that if you partially differentiate u with respect to t, you can get x t prime. Okay. And also you have to differentiate your u with respect to x 2 times partially, you can get x double prime t. Now just put those things in your equation 1. Okay, your given
স্যার
equation there
এক্স
ছিল।
টি প্রাইম আসলে কিভাবে স্যার একটু বলবেন স্যার?
Just হচ্ছে আমরা
এক
partially differentiate করছি with respect to x. Okay, so this will be counted as x double prime. দুইবার differentiate হচ্ছে, তাই না? So x double prime. Okay, so now you can say this is x double prime by x equals to t prime by t. Okay. Now, so I told my previous class that if your given equation is suppose like this, okay, that means higher order. If you get higher order partial derivatives, uh, for higher order partial derivatives, you can get here this thing, okay, which is double prime. So if you find that it will be a double prime, so you have to let a constant term which is minus lambda square. Okay, so আমরা প্রিভিয়াস যে ম্যাথটা করেছিলাম ওখানে কিন্তু হায়ার অর্ডার ছিল না ইকুয়েশনটা। ওকে, অনলি ফর আমাদের ফার্স্ট অর্ডার ফার্স্ট ডিগ্রি ইকুয়েশন ছিল। So for solving first order and first degree partial differential equation, you have to let only one constant, which is m. Okay, we just declare a constant which is m. Okay, but here you have to let the constant which is minus lambda square for proving or solving this kind of problems. Okay, just এতটুকু মাথায় রাখবা যে তোমাদের ফার্স্ট অর্ডার ফার্স্ট ডিগ্রি ডিফারেন্সিয়াল ইকুয়েশন partial differential equation solve এর জন্য always try to remember only just let n, the constant, okay, equals to n, but for higher order you have to let minus lambda square. এটা আমাদের সলভ করার সুবিধার জন্য। ওকে, so from here,
স্যার ফার্স্ট অর্ডার আসলে মাইনাস এন হয়
হ্যাঁ বলো।
স্যার, মাইনাস ল্যামডা স্কয়ার কখনো হয় আর যে মাইনাস এন কখনো হয় স্যার?
মাইনাস এন না, অনলি এন ছিল এখানে, তোমরা ল্যামডার জায়গায় মাইনাস এন স্কোয়ারও বলতে পারো, নো প্রবলেম। ওকে, জাস্ট মাথায় রাখবা যে আমি বললাম যখন ফার্স্ট অর্ডার ফার্স্ট ডিগ্রি ইকুয়েশন হচ্ছে, when this ফার্স্ট অর্ডার ফার্স্ট ডিগ্রি ইকুয়েশন, সেই ক্ষেত্রে অলওয়েজ যখন তোমরা এটা ডিফারেন্সিয়েট করে আসবে একটা প্রাইমে আসবে, এবং সেই ক্ষেত্রে অলওয়েজ সাইডে রিমেম্বার দিস ইকুয়ালস টু এন ধরে নিতে হবে। ওকে, বাট ফর হায়ার অর্ডার, যেখানে আমার হায়ার অর্ডার ছিল, ফর হায়ার অর্ডার ইউ হ্যাভ টু লেট minus lambda square. Okay, now
ওকে স্যার।
let's take a look here. Here you can say x double prime x equals to t prime t equals to minus lambda square. Now from here you can write it is so 5 is 6. Okay, and t prime plus square t, here it is 0, this is 7. So one of them is 6 and another one is equation 7. Okay, from these fractions. Okay, so first fraction and also the third one, you can get x prime plus lambda square x equals to 0. If you simplify these things, okay, and also for these two terms, you can get t prime plus lambda square t equals to 0. Okay, now you can solve this kind of problems easily. What is the solution of 6? Can anyone please tell me? What is the solution of equation 6? Anyone? Do you have any idea how can we solve this kind of equation? ওকে, তোমরা সবাইকে অর্ডিনারি ডিফারেনশিয়াল ইকুয়েশন করেছো? এটা কি সলভ করতে পারবে? How can we solve this kind of problem for ODE, ordinary differential equation? Do you remember anything? Ordinary differential equation করেছো সবাই? Okay. Do you have any idea about the auxiliary equation? Then the general solution which is consisting with a complementary function and particular integer? Okay. So to solve this kind of problems, you have to find out at first auxiliary equation. Okay. So for these things, for this reason, you have to find that which is m square plus lambda. That means here you can say d square plus lambda square y equals to 0. Okay. So you have to replace m instead of d. Okay. That means you have to let a trial solution y equal to e to the power mx at first. And after that, just differentiate your y with respect to x 2 times and then put those things in here. You can get this kind of auxiliary equation, which is m square plus lambda square equals to 0. Okay. From here, you can say that m square equals to minus lambda square. And also here you can say m square lambda square I square. And also you can say it will be plus minus lambda I. Okay. So this is your roots of this equation, and now you have to find out the complementary function from here. Okay. So you can say that if your roots are different, okay, then sorry, তোমাদের কি আসলে খেয়াল নেই কিভাবে অর্ডিনারি ডিফারেনশিয়াল ইকুয়েশন এরকম কিভাবে সলভ করতে হতো অক্সিলারি ইকুয়েশন বা কমপ্লিমেন্টারি ফাংশন আর পার্টিকুলার ইন্টিগ্রাল কিভাবে বের করতে এগুলো খেয়াল আছে তোমাদের? এনিওয়ান?
6 মাস আগের কথা স্যার, ভুলে গেছি।
ওকে ওকে, তো আমি আবার রিমাইন্ড করে দিচ্ছি। তো হিয়ার let's take a look at for similar roots. Okay, for distinct roots, that means m equals to m1, m1, m2, m3. That means roots are not equal. Okay, then the complementary function will be c1 e to the power m1x plus c2 e to the power m2x plus cn e to the power mx. Okay, so this is for distinct roots or different roots. That means আমি যে একটু আগে বের করলাম m equals to plus minus lambda I. This is our non-real roots. Okay, that means complex roots. But if m are distinct, okay, and real, So that's why the complementary function will be c1 e to the power m1x, c2 e to the power m2x, and ever. But for equal roots, the complementary function will be this is another case. Complementary function will be c1 plus c2x plus c3 x squared plus into e to the power n prime x. Okay, so here if our roots are equal and real, so you can say that the complementary function will be c1 plus c2x plus c3x squared. That means you have to multiply x. Uh, c2 এর সাথে x মাল্টিপ্লাই করছো, দেন c3 এর সাথে again আরো একটা x মাল্টিপ্লাই করতে হচ্ছে। ওকে, এভাবে করে যতটুকু পর্যন্ত যাচ্ছে রুটস যে কয়টা হবে, here m1 m2 and m3, then you have to write for c1 c2 and c3. Okay, or m1 m2 m3 m4, you have to write c1 c2 c3 c4. Okay, and also into e to the power m prime x. Okay, this is for equal roots. Okay, and for complex or imaginary roots or non-real roots, এসব ক্ষেত্রে কি হবে আমাদের equals to a plus minus ib. Okay, so for this kind of roots, you have to let the complementary function will be e to the power ax. Okay, এখানে জায়গা হচ্ছে না। For so for non-real roots, that means imaginary roots or complex roots, you have to say a complementary function will be e to the power ax a cos bx plus b sin bx. So this will be a complementary function. Okay. So here just take a look that this is also distinct root. So you can find this kind of equation. You already know that c1 e to the power a plus ib plus c2 e to the power a minus ib. Okay, so this is your complementary function, and after simplification you can get this, which is e to the power ax into a cos bx plus b sin bx. Okay, so this is your complementary function. So from here you can also say that what will be the solution of this equation using this thing? Just compare it with your these roots. Okay. Okay, after solving this, you can get here, this will be m square plus lambda square equals to 0. Okay, that means আমি আগেই বলেছি যে যখন এটার মানে হচ্ছে d square x by dx plus lambda square d x equals to 0. So এখান থেকে আমি লিখতে পারি m square plus lambda square equals to 0. Okay, so just replace a instead of d. Okay, so from here you can say this is m equals to plus minus lambda I. Okay, so this is our non-real roots. Okay, where m equals to, if m equals to a plus ib, you can say complementary function equals to e to the power ax a cos bx plus b sin bx. So if m equals to plus minus lambda I, what will be our complementary function? Anyone? Just compare these two things. you can get your required result, which is complementary function. Okay, so here a means 0, okay, and plus minus ib. ib, here b means lambda, okay. So if m equals to a plus ib, that means 0 plus I lambda, then you can say complementary function will be e to the power ax. That means 0 into x, sorry, 0 into x. That means e to the power 0. Okay. Here e to the power 0 into x into uh, also here what plus minus I lambda. Okay. So here you already see that IB, that means for this kind you can write A cos bx plus B sin bx. So you can say here A cos B means lambda. Okay. So lambda x plus B sin lambda x. Okay. So this is your complementary function. Okay. And also you can say this is the solution of this equation, because the right hand side equals to 0, and this is your homogeneous linear differential equation. Okay. So if the right hand side equals to 0, and this means this is your homogeneous linear differential equation, so that means you have not find out the, okay, I just say that for solving or finding the general solution, you have to write a complementary function plus particular integral. Okay, that means yc plus yp. Okay, আমরা যেভাবে ডিফারেনশিয়াল ইকুয়েশনটা সলভ করতাম সেটা হচ্ছে কমপ্লিমেন্টারি ফাংশন বের করতে হতো এবং সাথে পার্টিকুলার ইন্টিগ্রালটা যোগ করতে হতো। ওকে, বাট হিয়ার just take a look that here the right hand side, this is for homogeneous, that means f d y equals to q x. Okay. Suppose this is our equation which is non-homogeneous. Okay, that means right hand side is not equals to 0. Okay, so that's why you have to find out the particular integral also. But আমরা এখানে দেখো right hand side টা 0, so that means যে এখানে আমার particular integral টা বের করতে হচ্ছে না, particular integral টা already 0. Okay, so that's why the complementary function is our general solution. So here for you can say that the solution xx equals to a cos lambda x plus b sin lambda x. Okay, so this is your solution of equation 6. Okay, after that, okay, so yeah, okay, ওরা এখানে যেটা করেছে, ওরা এখানে এটাকে c1 এবং c2 বলেছে। This is your choice. Okay, let here c1 cos lambda x plus c2 sin lambda x. Now where x equals to c1 cos lambda x plus c2 sin lambda x. Now for solution of equation 7. Okay, this is the solution of equation 6. Now for solution of equation 7, it will be t equals to here c3 into the minus lambda square t. Okay, sorry. That's it. So here the solution of equation 7 will be t equals to c3 e to the power minus lambda square t. এটা সিমিলার ওয়েতে জাস্ট এখানে এটাকে যদি আমি মাইনাস lambda square করে দিই এবং এটাকে ডিভাইডেড বাই t করে দিই, দ্যাট মিন্স t prime equals to minus lambda square t, and after that t prime by t equals to minus lambda square, and just integrate these things, you can get ln t here minus lambda square t. Okay, integrate that, here, just simplify this equation. That means here you can get t equals to e to the power minus lambda square t plus c. Okay, then also you can just separate this thing to e to the power c into e to the power minus lambda square t, and also you can let e to the power c is, let us consider e to the power c, here it is 3. Okay, so because here for solution 6 you can say the constant is c1 and c2, and for 7 you have to let c3. Okay, so this is your x and t. Now you have to put this solution in your equation 5, which means ux comma t equals to xx and tt. Okay, so from
স্যার এটা সলভ ম্যাটেরিয়াল আছে না স্যার?
okay, here c1 of x okay. So this is your general solution of your given equation. Now you have to use your boundary conditions. Okay, and after that you have to find out the values of c1, c2, c3 from there. The main fact is that of the boundary value or boundary condition is you have to find out the values of c1, c2, and c3 from there. Okay, by using those boundary conditions. Okay, so here this is our equation 8. Now, two, now let's use 0 comma t equals to integral 1 minus lambda square t. Okay, এটাকে আরেকটু সিম্পলিফাই করে নিতে, just মাল্টিপ্লাই করে দিয়ে দেন এটাকে a okay, just multiply c3 with this term, then you can get c1 c3 and also c2 c3, and here c1 c3 is a and c2 c3 is b. Okay, and e to the power minus lambda square t will be here separately. Now from here, by using equation 2, you can get use 0 comma t. Zero, zero, one comma t here, square t e sin 0. And from there, and say sin. So we have to find out the values of a and b. Now from here you can say sin lambda equals to sin in pi. Okay. So now putting these values in equation, let us suppose this is equation 8. Okay, so from 8 you can say I just use those boundary conditions, and after that you find that the value of a, and also from using equation 3 you can get this term, and from there you can say here lambda equals to n pi. Now just put those things in here. Equation 8 you can get 8. Okay, 8 you can get u x and a just to the minus first and 5. So this is your equation 9. Okay, that's it. So you have to put those value of a and b in a and lambda in here, equation 8, and you can get another equation which is equation 9. So here you have also find out the values of b. For this uh, solution, you have to use superposition principle. Okay, now in my next class, I will discuss about superposition principle, and after that, I can show you. I will show you the values. How can we find out the values of G from here? Okay, that's all for today.